Hello everyone, let's try to be a cheat code ninja today. Let's solve a very interesting problem today. We are given a string s and an empty string t, and we have to perform operations on s and t till they are both empty. In the first operation, we have to remove the first character from string s and append it to string t. In the second operation, we have to remove the last character from string t and append it to a paper. Let's represent the paper as string p. And we have to return the lexicographically smallest string that can be written on the paper. This means the string which would appear first in a dictionary. Let's look at an example. Here we are given a string s, zza, and string t and string p are empty. To derive the lexicographically smallest string, we have to perform the first operation 3 times. Hence we would remove character z, za, and then place it in string t in that order. And now we have to perform operation 2 3 times. Hence we would append characters a, z, z into string p in that order. And string p would be the lexicographically smallest string that is possible. Hence this is our answer. Let's look at a more difficult example. Here we are given a string b, d, d, a. Since the smallest character in the string is a, any string that starts with character A is going to be lexicographically smaller than any string that starts with character B. And similarly, any string that starts with character B is going to be lexicographically smaller than any string that starts with character D. Hence, we would try to put character A in the first position in string P. And to do that, we have to first bring character A into string T. Hence, we would remove all the characters from string S and add it to string T. Till that time, we would refrain from taking any character from string T and adding it to string P, because it would result in a lexicographically larger string. And since there are no more characters left in string S that we could use to make our resulting string lexicographically smallest, we have to add all the characters from string T in reverse order. Hence, our resulting string would be A, D, D, B. Let's see how we can come up with an intuitive solution for this problem. Let's take this string as our example. Since A is the smallest character in the string, we would try to place it first in our resulting string. Hence, we would have to bring it to string T. Now, since there aren't any characters left in string S which are smaller than our last character in string T, we have to compare with the last character in string T because that is the character that will first go into string P. Hence, we could add character A into string P. And now we would have two choices. Whether to add character B into our resulting string or search for any smaller character that are possible in string S. As we can see that string S has a character A that is smaller than character B, which is the last character in string T. Hence we would try to place it before anything else into our resulting string. So let's do that. And since now there are no more characters in string S which are smaller than the last character in string B, we would place it into our resulting string. And now since there is a smaller character in string S than the last character on string T, we would try to place it before anything else. And now we would place the last two remaining characters CC. Now let's try to think about the data structures that we will be needing to solve this problem. For T, we have to be able to add characters at the end, check character at the end, and also remove characters from the end. Hence, stack is a perfect data structure for this. For string S, we have to keep track of all the characters that are remaining in string S. Hence, we could keep a hash map where the key would be the character and the value would be its count. And the time complexity would be, since we'll be adding each character and removing each character from the stack only once, it would be O of n. And for each of those characters, we also have to compare whether it is smaller than the characters remaining in S. So our complexity is O of 26n, which is the same as O of n. And for the space complexity, we would be needing a stack to store the n characters in string t, and also a hash map of size 26 to store the characters in string S. Hence, our space complexity would be O of 26 plus n, which would be just O of n. Let's implement our solution. Let's use a counter object to store the characters in S. For t and p, we could initialize a stack and an array. And now let's go through all the characters in string S one by one. Let's first append it at the end of t. And since now we have used that character, let's decrement its count by 1. And if its count becomes 0, let's remove it from our map. And now here is the tricky part. We have to check if there are still characters remaining in S and one of them is smaller than the last character in T. If such a character exists, then in that case, we cannot use the last character in T. Otherwise, we could directly use the last character in T because it's the best character that is available to us. Hence, while the map and the stack T is non-empty, and if there isn't any character in the map that is smaller than the last character in T, we would append the last character in T into a result. At the end, we may have some characters remaining in T. The only way they can be included in the output is by taking them from the last. Hence, we reverse our stack T and then add it to our output. At the end, we are just joining our array P to generate a string. Now our solution is complete. Let's submit it. As you can see, our solution is accepted. If you have any doubts or concerns regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel. Thanks for watching.